Okay, this is my 1,000 watt laser at 50% at 2,000 millimeters a second. What we're trying to do is cut through the top piece of plastic on this foam. So I'm going to turn it on and we'll see how it does. Okay. So at 50%, looks like we got maybe, I don't know, maybe 3/8 of an inch through. All the way through the material. That's at 50%. And if I try to break this, there it goes. Sorry, doing this in my basement where my laser is, but you can see that it made a very clean cut, which is what I would have expected. So we'll try another one here. So we'll put that back in. And I'm going to come over here and I'm going to change the power here. We'll go to 30%. And I'll index the head down a little. We'll try this again. So this is at 30%. So 300 watts is the target. Now on these machines that I've got, that it's Chinese, not the most accurate, but let's give this a whirl here. Okay, it definitely cut, or at least it made a line. So let's see. So if you look on the end that I didn't break, you can see right here the depth of cut is a little bit less, which would make sense because the power of the laser is lower. There is a little bit of a kind of a gas out. So as you're vaporizing the plastic, you'll see that there's like a tiny burr on top of it, but it did make it through. So if I come down here to the other side and if I break this, see, it made it through. Now it's not, now remember, we're not trying to cut all the way through the material. We're just trying to cut that piece of plastic on top. And if we hit that, if we can get the line going, I would be willing to bet that we could chase that in correlation. I'm moving, this laser is probably moving faster than what you would need to move in order to make that that cut. But anyway, this is just a proof of concept to do something where you don't have that cut-off wheel, or you're trying to resharpen or break off blades. This is a perfect application for a CO2 laser. Now mine is a water-cooled laser. There's a bucket of water over here. I would recommend getting maybe one that's air-cooled, so more of a solid state. You don't need anything more than the CO2. It'd be maybe a couple $1,000s. And what you would do is basically the same kind of setup that you see on my laser here. So you'll see that there's a moving cutting head, and there's a mirror. And then there's a mirror inside the mount. You can't, there it is. And then that mirror bounces to another mirror, which is right there. And then that mirror is going to the laser tube. Now, I wouldn't recommend like this kind of a setup. I would mount the cutting head on your current gantry. So it's basically the same thing. There's a couple of bearings here. There's a stepper motor that makes it move back and forth. Same thing here. So that cutter head would go where the cutoff wheel would be, and then I would mount a station. I would either I would probably mount a mirror like that, and then I'd make the laser tube over there, and I'd keep it just like that. So the laser tube is mounted in line with this axis, and then it would fire the laser over to here, bounce it to the cut head, and then the cut head would cut. And the cool thing about it is that it's a laser, and the focal point is set by the cutting head. So this thing can move back and forth this way, and it doesn't matter. It will produce the same amount of power and the same amount of cut line for it. So this is an option for you if you want to see about changing this. And then if we get the registration marks to work, then it's just a matter of timing the speed of the cutter with the laser and getting that line to line up. And yeah, that, it's another option at least to take a look at.